Fatma, and the topic I'm going to discuss today is Mondia IT. First, we will introduce it. Mondia IT Skills is a member of Apocynaceae, previously in the family Asclepiadaceae subfamily Periplocodiae. The species was initially placed in the genus Chlorocordon. This was later then changed to Mondia because the former name was are homonyms used for a genus of ericaceous plants. The genus Mondia skills consist of two species, M. whitei and Mondia coronata bullock. Both species have same physical appearance. However, the structure and the number of cornea lobes are distinct features between the two species. M. whitei is commonly known as a white ginger tonic root or Mondia armondi as name from which the generic name was derived. Interestingly, the specific epithet Whitei was in honor of collector Mr. A.S. Whitei of Fern Natal, who motivated the transfer of species to Royal Botanical Garden in Kew, England for documentation. M. whitei is an endemic African species useful to the populace since ancient times. Some of the important uses of M. whitei are medical, cultural, and nutritional. Most of the plant material is collected from the wild, and this has contributed significantly to its valuable status. In most countries where M. whitei is found, the commercial cultivation of species is minimal or does not exist, which has further impacted upon its conservation. In the view of economic potential of MIT, especially the medical uses, we decided to search and collect the available information on the species via electronic and library searches. This review examines the various studies on MITs and attempt to highlight the benefit that may be derived from the plant. From the published data, some absorbed loopholes as well as the neglected research areas on MIT were also identified for possible attention from researchers. In addition, this review strongly endorses the commercialization of MIT in South Africa based on its extensive usage by local populace. It is hoped that this review will produce useful material to researchers, conservationists, policy makers, as well government agencies that require detailed overview of general uses, possible conservation methods, and economical potential of MIT. Morphology of MIT. MIT is a perennial woody climber reaching 3-6 meter height with twining stems which exudes white lactus when cut. The figure 8. Here we shows the figure. A. Creeping and well absorbed on an iron bar leaves. It has characterized large possibility positioned heart-shaped leaves in figure B. As you can see, the surface of leaf are endowed with soft hairs and distinctive star-shaped stipules. The attractive flowers are reddish purple in color. At the body, it branched inflorescences in figure C. Flowers are assumed to be pollinated by flies and are relatively short-lived, serving for 3-4 days. The flowering season ranging from October to March, peaking between November and January, south quarter, and from August to May to August, peaking in June to July, north of equator. MIT grows from large tuberous root stock, and roots have a very distinct medulla arma, which has attributed to the presence of 2-hydroxy 4-methyl oxybenzoaldehyde. The roots grow laterally and may separate out just beneath the soil surface, covering large areas, making them easy to harvest. The fruit is an ovid follicle with which diseases to release an estimated 180 to 320 compost seeds that are wind dispersed. Here is the diagram. twinning team with and young birds and fully open flowers, mature roots. Now distribution of MYT. MYT is an endemic in almost all African regions with the exceptions of northern part of continent. MYT predominantly occurs in moist to wet forest. It is found in vegetation types that range from swamp forest, swampy shrubby grassland and riverine forest to distributed forest at altitudes from sea level to 1800 meter. In West Africa, the species is commonly found in Guinea, Ghana, and Nigeria, whereas in the Central Africa region it occurs in Cameroon, Kenya, Tanzania, and Uganda are countries where MYT is found in East Africa, South Africa, Malawi, Angola, Mozambique, and Zimbabwe are southern African countries where this species has been recorded. In South Africa, MYT is mainly found in KwaZulu-Natal and Limpopo provinces. In KwaZulu-Natal, the species is restricted to the midland as well as lower frost-free elevations, often near the coastal areas where the colonies were becoming scarce. In protected forms, herbarium specimens examined by mentor indicated locations such as Maku's nature reservoirs, Mpageni village, and Mfandiswin as area where MYT occurs in the province of KwaZulu-Natal. Uses of MYT. Medicinal uses. MYT is a versatile plant with many uses which are either documented or passed down to subsequent generations by word of mouth. Across various ethnic groups in Africa, MYT is known as a mild laxative to ease abdominal pains, alleviate nausea, as well as for the treatment of fever, bilharzia, and sexual dysfunction. Beside ancient documentation of uses of MYT, more recent ethnobotanical surveys continually cite the local uses of species. A root decoction of MYT is documented to induce labor in Uganda, fight malaria infection in Benin and Nigeria, eradicate worm infestation in Nigeria, cure male infertility in Cameroon. In Kenya, a survey showed that MYT is practically used for many problems, for example, ringworm, skin diseases, stomach worms, heart diseases, asthma. In addition, the species is used for unspecified groups in South Africa to treat stress, tension in adults. Highlight that South Africa use MYT to stimulate appetite as an aphrodisiac and for treatment of fits in children. A number of scientific studies involving the use of different solvent extracts of MYT parts have been performed for various workers. These include biological assays investigating the aphrodisiac, antimicrobial, anti-inflammatory, anti-triosinous, and antioxidant activities. Most of assays attempt to investigate the efficacy of plant extracts against major health problems encountered by humans. MYT extracts have shown great potential in most of biological activities investigating, thus validating most of its traditional uses since ancient time, particularly the investigation for aphrodiscus efficacy of MYT rose yielding positive result. Some aldehydes are Aphrodiscus efficacy of MYT rose yielded positive results from some aldehydes are cardiotoxic against certain types of cancer in vitro, as this may be due to inhibitions of prosinase. It was decided to investigate MYT for possible anti-cancer activities against various. The efficacy of MYT extract against mental, neurological, or behavioral problems via in vivo and in vitro systems has all received intense investigation by our group. RCPGD, in collaboration with the Department of Medicinal Chemistry, University of Copenhagen, Denmark, recently a monoterpenes lactone oleoid, which was responsible for in vitro serotonin transporter affinity, was isolated owing to the unique nature of isolated compound. Further studies to elucidate the CRT inhibition mechanism as well as in the in vivo efficacy are ongoing, although most studies investigation the biological activities of numerous medicinal species such as MYT are based on one plant on target approaches. Traditional medicine often use the combination of two or more plant extracts at a time. As a result of this practice, a number of studies have also investigated formulation which consisted of MYD in treatment of skin, sickle cell anemia, and sexual dysfunction. The authors reported favorable results with the formulation containing MYD. However, the impact of MYD in the absorbed responses remain very difficult to explain due to the complex nature of interaction with other plant species in formulation. Nutritional properties. From antiquity, various organ parts of MYT, such as leaves, roots, tubers, have been utilized as food, as documented by Gerstner. The Zulus in South Africa use the root as an appetite stimulant. Several flavored drinks have been obtained from the roots during wedding in several West African countries. The roots are used to make a beverage similarly to ginger beer or ale, or are brewed in alcohol to make an energizing drink. In South Africa, the root is sometimes cooked with meat to enhance the flavor and also used as a tea. In Kenya, the roots are eaten fresh or dried, initially tasting rather hot and bitter, then slightly sweeter afterward. In Angola, MYT is served as an alternative food for the elderly Portuguese and their neighboring locals who boil the leaves with butter or olive oil, serving as a substitute for spinach. In KwaZulu-Natal, South Africa, leaves are eaten as a pot herb or imifino, and the dried powder leaves are added to food as a condiment. Muccioni reported that MYT leaves have more nutritional value than other regularly used animal feeds, but it proved unpalatable to goats. Nevertheless, it seemed to increase milk production in Parisian cow in Uganda. The tubers are commonly consumed, however, the taste varies depending on the age of plant. Young tubers are sweet tasting, whereas the mature tubers have a slightly bitter taste, probably because of the accumulation of secondary metabolites. MYT contains vitamin A, D, K, and E, as well as magnesium, zinc, iron, calcium, and protein. As a result, MYT may be readily an affordable alternative source for prevention of micronutrient deficiency, especially among poor population. UQ estimated the nutritional value of MYT to be 280.8 kilocalories per 100 gram. In addition, an in vivo study to determine the effect of MYT extract on the endorsements of rats subjected to intense physical activities was performed. The author discovered that the rats fed with meal supplemented with 0.61% MYT were better adapted to physical efforts with performance deficiency, approximately 6% with respect to the control group. Pharmacological study on Mondia widely across various African countries with biological activities assayed at resultant effects. Countries of collections: cardamom, part juiced, root bark, extracting solvent, water. Biological activities reversible in vivo anti-perma spermatogenic and anti-fertility activities, absorption and results, inhibition of spermatogenesis and reduce fertility. Next country is again hormone. Parts are used are root, extraction, solvent or water. Biological activities are in vivo, androgenic activities. The results are increase in serum and anti intratesticular testosterone level after chronic treatment. Next country is hormone. Part uses roots, the solvent or extract or hexane. Biological activities are in vivo, androgenic activities. The results are had a reversible androgenic effect and potentiate the dation of non-epinephrine on rat. What's difference? Again, hormone. The part extracts are the part uses roots. The extraction solvent are hexane, methylene, chloride, methanol. Biological activities that are evaluated are in vivo androgenic activities. Results are hexane fraction had a significant inhibition against the contraction included by potassium chloride, and underlying include contraction oscillated was a difference. Again, hormone. The part uses roots. Traction solvents are hexane, water, and methylene chloride. Activities are in vivo practical activities. Methyl results are methylene chloride fraction result relax the smooth muscle of guinea pig corpus. Intromission and rectal frequencies of inexperienced male rats. Hormone. The roots are used. The solvents are water. Biological activities extraction are in vitro antioxidant, anti-amylase, and anti-lipase activities. Results are those significant bioactivities were detected in three assays. Hormone root part used are roots, solvent extraction are methanol. Biological activities evaluated are in vitro antioxidant activities extracted had high hydroxyl radical scavenging activities, while antioxidant activities in other assays were low. Ghana part are used are roots. Solvents are ethanol. Biological activities evaluated are in vivo aphrodis activity. Absorption result are a dose of 200 milligram per kilogram improved and sustained action probably through activation of nitric oxide synthase activity. Kidea part are used are roots, solvent or ethanol that are extract. Biological activities evaluated in vitro tricinase inhibitory activity. Results are inhibition of oxidation of L3 dehydroxyphenylalanine LDOPA with ID50 of 4.3 milliliter. Kidney powder used are roots. Solvents that are extracted are hexane, methanol water. Biological activities evaluated in vitro anti-inflammatory activities. Results are hexane and methanol extract had high above 80% cyclooxygenase 1 enzyme inhibition. Again, Kenya, the part that are used are roots. Solvent extraction are hexane, methanol water. Biological activities evaluated are intro antibacterial activities. Results are no significant antibacterial activities detected using the agar disk diffusion assays. Criteria part are user leaves. Solvents are hexane, methanol, water. In vitro anti biological activities are in vitro anti-inflammatory activities. Result methanol and water extracts had moderate above 65% COX-1 inhibition. Physicochemical characteristics of dried roots of Mondia Whitei. Physicochemical parameters, and on the other side is quantity in milligram 100 gram dry matter. Water content are 98.0 to 0.80, ash matter 7950.0, more or less are 50.00, proteins are 1882.0 and less is 8.00, total sugar 53670.0 and less 174.00, liquid matter 2950.0 less 50.00, total reducing power vitamin C equivalent 0.966 and 10.2800, phenolic compounds 24.202 and 0.1060 cell. As you can see in this table, other quantities are given such as phenolic compounds, aluminase, calcium, manganese, iron, sodium and copper. Next are uses are other traditional general uses. The woody middle part of thicker root is used as a toothbrush in folic medicine. The Luhiya community of Western Kenya drew the root for good luck before setting out to perform difficult tasks as a cure. In folk medicine, the Luha community of Western Kenya chew the roots for good luck before setting out to perform a difficult task as a cure for bewitchment, as a love potion to overcome long hangovers, a symbol of peace and sign of power. In the past, the seeds were apparently used as a point and arrow poison during hunting. In South Africa, the stems are well bitten to yield long and shiny strands tough enough to be used for the making of ropes, as brightly colored flowers are very attractive. It is highly recommended for the cultivations as a garden plant, thereby adding to its horticultural potential. It is a vigorous, fast-growing plant which make it ideal to overcover. Trellis is based on the sweet vanilla-like flavor. When they can Greek predicted that MBT has the potential to be a novel African fragrance or spice. Father Gerstner described the taste of roots as a first bitter, then afterwards sweet. This is reminiscent of vanilla, ginger, marzipan, cinnamon, and liqueurized. Therefore, the aromatic roots of MBT could become a useful food flavoring agent. Physicochemical and nutritional analysis of root and leaves of Mondia. Potassium in roots are 11.34, in leaves 32.05, sodium in roots are 5.61, in leaves are 24, magnesium in roots are 1.40, in leaves 2.83, calcium 3.08, in leaves 8.25, iron 0.20, in leaves 0.43, zinc in roots are 0.03, in leaves 0.07, copper 0.003 in leaves and 0.06 in leaves. Manganese in roots are 0.64, in leaves are 0.05. Cadmium and lead are trace in roots and trace in leaves. Root protein in roots are 4.35, in leaves are 21.8. Beta carotene in roots are 0.004, in leaves 0.022. Thiamine in roots are 0.78 and leaves 3.70. Dikit in roots are 0.52, in leaves are 8.15. Riboflavin in roots are 0.62, in leaves are 2.45. Dose in roots are 0.008, in leaves are 0.015. Axolose in roots are 9.17, in leaves 18.70. Glucose in roots are 2.40, in leaves 9.0. Chemical and photochemical studies. Compound isolated from MYT. Despite its long use, only few studies exist on the isolation of bioactive compounds from MYT. The most common and well-known compound isolated from MYT is 2-hydroxy-4-methoxybenzaldehyde, which is a potent tricinase inhibitor. The compound has also been isolated from MYT by earlier researchers, as highlighted by Corbinelli et al. In addition, the author reported for the first time the isolation of isovanillin, previously thought to be synthetic from MYT. Subsequently, the first report of isolation of coumarins and chrominolygin, as well as chlorinated coumarinolygin from the genus Mondia, was reported. Recently, bioassays guided isolation lead to the isolation of leolite, which showed affinity to CERT. A binding assays the structure of some compounds 1 to 6 that have been isolated from MYT are depicted in figure 2. A number of other compounds have also been isolated from MYT, as stated by other authors. Relative to high number of uses in traditional medicine, as well as the published articles on the preliminary screening of cord extracts, the number of isolated compounds is rather small. Particularly, investigation on MYT as an aphrodisiac have been extensive, yet the compounds responsible for the absorbed effects both in vitro and in vivo remain to be isolated. This leaves us with the challenge to conduct more stringent research to isolate the identify more novel bioactive compounds from this species. Photochemical studies of MYT. A recent qualitative photochemical analysis of ethanol extracts from MYT indicate the presence of reducing sugars and triterpenes. However, other essential photochemical groups such as alkaloids, flavonoids, and phenolics and saponases were not detected. Subsequently, the presence of phenolic, flavonoid, and tetrate in this species have found. The author further reported antioxidant activities of extract via its high scavenging activities. Ethanol detected a phenolic content of 4.32 mg to gram of catechin equivalent in MYT extract. Some scholars have suggested that the presence of a wide range of plant secondary metabolites such as phenolic, flavonoids, and tannins in plants have direct correlation to exhibited biological activities. For instance, attributed antioxidant bioactivity to presence of phenolic in plants. Since these plants secondary metabolites reacted MYT could have partially contributed to some of the absorbed bioactivities, and investigation of physiochemical characteristics of MYT has also been reported. Based on the result outlined tables 2 and A3, MYT can easily serve as an essential mineral and vitamin supplement. However, there are high level of disparities in some of the parameters. For example, values of calcium, magnesium, protein in table 2 and 3, and this remains a major concern. There are a number of attributing factors such as collection, localates, and seasonal variation effects and method of analysis which could explain the observed disparities. More studies are strongly recommended taking these factors into account, as well as using more sensitive equipment. Here are the chemical structure of compound isolated from Mondia Whitei. Conservation strategy for MYT. Oxybutyl defined conservation as a process involved in the preservation and careful management of environment as well as natural resources to prevent neglect over exploitation and destruction. Globally, most natural resources, especially medicinal plants, are under strain due to the increasing urbanization and increased demand for population. This high demand has led to the indiscriminate harvesting and over exploitation of natural flora within all the ecosystem. In South Africa, the problem of medical plant over exploitation is not a recent one. As early as 1946, Father Jock Gerstern, a Zululand missionary, predicted the alarming extension of domed plant species used for the traditional medicine. In particular, Jagger and Van Stadent identified the increased use of the non-renewable plants materials such as wood, bulbs, bark as a major contributing factor in the decline of the most species. Wild MYT is a slow-growing plant that takes about 15 years to attain a tuber of sufficient size for consumption. The ecological implication of intense harvesting of such as slow-growing plant to satisfy the ever-increasing demand are that harvesting from the wild is unsustainable and species may become that indeed the plant is reported to be scarce and difficult to locate in wild. Around 1898, local extermination of MYD had been recorded in Durban area of South Africa due to the location of its route. In past, MYD was reported by the conservation strategies such as traditional seasonal restrictions on harvesting the species and taboo against the gathering of traditional medicine by menstruating women. Nevertheless, as a result of cultural change, increased entry of more amateur gatherers into the medical plant trade due to rising unemployment levels, these insurance controls are rapidly breaking down. According to Southern African Red data list, MYT used to be listed as a valuable species. However, it has now been evaluated to endangered status. Further evidence of the threats to MYT was reported by and Devon et al., who listed the species as one of the 9 species that is scarce and threatened in Zululand in eastern Africa. It is also reported that MYT has been classified as an endangered species requiring immediate protection for extinction due to over-exploitation. Generally, South Africa has low success rate in the use of law enforcement for biodiversity conservation. Therefore, a new approach that involves the stimulation of medicinal plant cultivation has been recommended. The domestication of medicinal plants will create new opportunities as an alternative to additional sources of income and help reduce the pressure on the wild plant, natural medicinal plant population. It is identified by is as a popular plant species that can be easily propagated in South Africa communal garden to counter the problem of extension. Thus has demonstrated by using seeds which easily germinate after 2 weeks. Alternatively, tip cutting can also be used for propagation. Generally, community-based medicinal plant farming coupled with the provision of subsidy and training in basic effective propagation techniques would enhance conservation of medicinal plants. A model example of this was implemented in India, where it used tree control soil drenching to increase the plant growth and the yield of tubers with enhanced flavor content of the Calpus Hamiltoni White and on plantulets. The author developed a micropropagation protocol used to produce a large number of good plantlets which were given to the tribal people in the hill region, providing them with both food and medicine. Another approach is the use of plant part substitution as a means for sustainable harvesting. Several workers have recommended that the non-destructive medicinal plant part, particularly the leaf, should be investigated for possible bioactivity. For instance, reported a better ethylenic activity in Cathia drigi leaves extract than in the root, which is frequently used in traditional medicine. As evidence in this review, most of studies on MYD have focused on the root bark extract, which is an indication of high stress on the underground plant part. Zukochi and Van Steden also suggested that traditional healers should be encouraged to use related plant species where similar biological activities have been demonstrated. The use of exotic cinnamomum zelanicum to replace MYT, for example, has long been suggested by Cunningham there in a 1988. Therefore, it is necessary to investigate a possible replacement species for similar biological activities which MYT has exhibited. Furthermore, South African scientists have attempted to overcome the challenge of partial extension of MYT through the use of biotechnological techniques. Tissue culture, regenerated plantulets are ideal for mass propagation of many species such as MYT due to the numerous advantages associated with in vitro techniques. Using the micropropagation technique, an estimated 2000 plantulets could be produced from a single seed after 7-8 subculture cycle at a 4-6 week interval. Subsequently, these plantulets were easily rooted after 3 months. Zboloidal also successfully rooted MYT shoot cutting in naphthalene acetic acid of neighboring concentration. It was observed that shoot cutting cultured in 0.5 milligram or 1 NAA were significantly higher in terms of number of roots as well as the root length. Nevertheless, the use of new and more potent plant growth hormones such as metabolines to enhance the efficiency of micropropagation protocols in peritonate. Presently, we are investigating the effects of metabolines as well as the application of hairy root culture in MYT to examine the production of main secondary metabolite to hydroxy 2,4 methanol oxybenzaldehyde. Generally, hairy root culture are characterized by high biosynthetic capacity and genetic fidelity as well as biochemical stability, although more expensive compared to chemical synthesis. Hair culture in MYT serves as a natural source and may offer an alternative prospect for investigation of biosynthesis pathways and commercial production of secondary metabolites such as 2-hydroxy-4-methyloxybenzaldehyde. The graph showing the frequency and plant parts. Now, economical status and commercial prospects of MYT. Economic status of MYT. Approximately 80% of population in Asian and African countries depend upon traditional medicine for primary health care. In the last 2 decades, the developing countries have witnessed a significant rise in the demand for herbal medicine, with global sales estimated at $60 billion. This is evidence in the expansion of scientific research relating to traditional medicine and transnational market for traditional medical line products. The trade of medical plants is increasing locally, regionally, internationally. In most countries where MYT occurs, there is no detailed data on harvest and trades of species. A recent rapid appraisal, however, indicated that the species wholesales for better $0.20 to 0.30 per kilogram and rated at more than $2 per kilogram. In Kenya, fresh roots were sold for $7 to 12 per kilogram. MYT collected for gathers from natural forest can generated from can estimated $3,600 per year. In Uganda, the average price per piece 0.01 to 0.02 meter in diameter and 0.3 to 0.4 meter in length. Our kilogram of roots increases from the collector US dollar 0.60 per kilogram. Middleman US dollar 1.20 per kilogram. Finally, to the retailers US dollar 1.50 kilogram to the better of knowledge in South Africa. However, there is no available publishment data on the average price of MYD. Therefore, the contribution of this species to social economical livelihoods, especially in South Africa, requires investigations. Commercial prospects of MYT in South Africa and identified the local understanding with respect to the cultivation and economical production useful indigenous plants, especially the medicinal species, are one of the most limiting factor in their commercialization. The author observed that the producers do not engage in commercialization because there is no indication of potential profit from the producing for local and international market in KwaZulu-Natal. However, commercialization of indigenous plants seems to be well developed in the informal sector with a large and active trade all year round. Makunja et al. Also acknowledged that the informal sector was generally well established but still remained an underground economy. The authors highlighted and strongly recommended the need to explore the untapped potential of formal medical sector for the MIT. Most available studies and literature focus on the pharmacology, taxonomy, and nutrition aspects only. In Kenya, a Mondia tonic has been registered as a food supplement in the Kenya Bureau of Standards with the Kenya Industrial Property Institution. In the contrast with the commercial potential of MYT in South Africa has remained unexploited even for medical and purposes. Evidence suggested that a demand for traditional medicine continuing to grow in South Africa. This has been attributed to the growing human population through the low employment growth rate, the influx of foreigners seeking work, and the limited resources of government to serve primary healthcare. International strong cultural attachment by many communities to traditional practices, even within the modernized urban cities, sustains the demand for traditional plant products despite the high utilization of species in South Africa. The lack of commercialization of species is over some and remain a major question and deserve more stringent studies, potentially in pharmaceutical and nutritional industries. As evidence in this view, number of studies on MYT efficiency against various elements increasing diseases such as erectile dysfunction, epilepsy, dispersion, inflammation, microbial infection are of great concern worldwide. Erectile dysfunction, which has remained rampant among young men aged 40 to 70 years, in the inability to achieve the maintenance on erection sufficient to permit satisfactory sexual intercourse because of some physiological and psychological factors. Using various approaches and assays techniques, different researchers have investigated the efficacy of MYT on erectile dysfunction. Most of the authors observed that extracts from MYT have significant positive aphrodisiac effect or sexual drive, thereby alternating erectile dysfunction. Fountains report that the root extracts caused an increase in amount, intermission, and practical frequencies of inexperienced male rats. Although the majority of investigation of aphrodisiac activity MYT is credited to Watch's group, other research groups have also been. In recent time, besides the aphrodisiac activities, there have also been numerous studies on the efficacy of MYT on studies such as epilepsy, depression, and mental disorder. According to WHO, an estimated 50 million people worldwide have epilepsy, with almost 90% of these people being in developing countries. MYT extraction has exhibited noteworthy effect on the disease and reported in many published articles and more active research ongoing. Triacinase is postulated to play a role in formation of neuromelanin in human brain and could be essential to dopamine neurotoxicity in addition to contributing to the neurodegeneration associated with Parkinson's disease. However, it has been observed that a 2-hydroxyl 4-methoxybenzylaldehyde is a potent atrocinase inhibitor. Therefore, MYD has a potential to combat the above mentioned problem. Moving to inhibitory compound present in the species, the efficacy of MYD against microbial and helminth infection has been studied. Most of published results, especially the antibiotical activities, were not promising. However, Sporigetal observed a moderate anti-schistosomiasis activities of water extract. Hence, we suggest the need for further investigation of antimicrobial efficacy of MYD on other microbial strain. As MYD is widely used against microbial related elements, the use of MYD against most of these devastating diseases coupled with active research served as a potential ethnomorphology leads to a discovery of novel and more efficient therapeutics. Again, considering the number of disease studies on MYD, the possibility of discovering new compound which could be of high therapeutic value cannot be overlooked. In event of such discovery, it will lead to more interest from the large pharmaceutical companies, both local and international, with the sole purpose of accessing large volume of plant material. In terms of nutritional potential, MYD could serve as another natural source of essential mineral vitamin supplements. Similarly, UQ studies suggested that utilization of MYD as an alternative food supplement to enhance the performance of sportsmen and women without the fear of ban associated with drug dropping potential. In cosmeceutical and agricultural industries, the enzyme triacinase is responsible for melanization in animals, regulates melanogenesis in mammals. Abnormal melanin pigmentation such as freckles and melasma are considered by humans to not be aesthetically pleasing. However, these problems can partially suppressed by deactivating triacinase. As various papers suggest, MYD contain triacinase inhibitor. There is a great potential for it in the cosmetic industry. The importance of this unusual phenolic compound 2-hydroxy 4-methoxybenzylaldehyde has been emphasized, characterized, and quantified in Hemidensis index Cartel. Furthermore, this insecticidal activities of compound was investigating using the roots of the Hamiltoni, and it was demonstrated against 3 kilo per terrain stored produced pests. Authors reported potential incidental activities and encouraged its uses because of the simplicity of its application, retention of viability of seeds, and the low toxicity. Both D-hamilotine and MYD contain 2-hydroxy 4-methoxybenzylaldehyde, which indicates that MYD could be used as antioxidant. Interesting, these two species have a number of similarities with MYD in addition to being member of the same subfamily Pyrrolosidia. Hence, the chance of successful application of similar techniques and derived use from the two species are high with MYD. That's all for my presentation. Thank you.